So let's just put everything together here, not only from function notation, but also from what we've talked about in the previous lectures as well. So we have this function f of x is equal to x squared minus 2x minus 3. We want to know, is the point 1 negative 3 on the graph? So to verify that a point's on the graph, let's just find f of 1 and see if it's negative 3. If it's not, then no, it's not on the graph, because there can only be one output when I plug in 1. So we do 1 squared minus 2 times 1 minus 3. 1 squared is 1, minus 2 minus 3. So 1 minus 2 is negative 1, minus 3 is not negative 3. And so, no, the point 1, negative 3 is not on the graph. All right, so that was easy enough. Now let's find all the values of x so that x comma 5 is on the graph. Okay, so 5 is the output. So we want f of x to equal 5. And we know that f of x is equal to x squared minus 2x minus 3. So we want x squared minus 2x minus 3 to equal 5. So let's subtract 5. And that gives us x squared minus 2x minus 8 equals 0. And now that I'm equal to 0, I can use the zero product property as long as I can factor this. I hope it factors, because that's my favorite way to solve a polynomial. Let's see, what multiplies to give me negative 8 and adds to give me negative 2? Minus 4 plus 2. So x is equal to 4 and x is equal to negative 2. So I just found all the values of x so that x comma 5 is on the graph. Cool. And I can check this by plugging back 4 into here. 4 squared is negative 16, or 16, sorry. Minus 8 gives me 8. Minus 3 is 5 for sure. Let's plug in negative 2. Negative 2 squared is 4. Plus another 4 is 8. Minus 3 is 5. Hey, they both work. Now let's find all the y-intercepts of the graph. Now, if this is a function, there should only be one y-intercept, because I'm plugging 0 in for x, and there can only be one output for every input. So if I plug 0 in for x, and I'm looking for the y value, let's go ahead and do that. F of x, oops, sorry, not f of x. F of 0 is what I'm looking for. And so that's going to be 0 squared minus 2 times 0 minus 3. So that gives me negative 3. So 0, negative 3 is the y-intercept, and it's the only one. Now let's look for the x-intercepts. So I'm going to plug 0 in for y. So x squared minus 2x minus 3 should be equal to 0. And again, it looks like I can factor, which is my favorite way to solve a polynomial. So we have minus 3 plus 1. So x equals 3, x equals negative 1. But these are x-intercepts, so I want to write them as ordered pairs. So 3, 0, and negative 1, 0. Those are my x-intercepts on the graph, okay? So when we're talking about the graph, we want to talk about ordered pairs. I only wrote these as x equals 4 and x equals negative 2 because it had already framed this as an ordered pair. If I wanted to write my answer as 4 comma 5 and negative 2 comma 5, I could have done that as well. But when we're talking about points on a graph, we definitely want to write ordered pairs. All right. So there's a lot to unpack there, but most of it was review. It was just the function notation that was the new stuff. And again, if you need to rewatch that, try it again. That's fine. You can do, if this isn't working for you, there are videos on Pearson MyLab that correspond to the different types of problems that we do. And so you can watch the video in the prerequisite part of the study plan, and then you can do the little quiz me's to make sure that you understand the problem before you attempt the problem set. All right, so this difference quotient, this is going to take some space and some time, so I'm going to pick this up in the next video.